So let's go ahead and get started. Welcome everyone here. My name's Tim Fox and I'm with Elephant Scale. And we're going to be talking today about a webinar about building a career in data science. And so let's, let me just first introduce myself. So I'm Tim Fox. I'm with Elephant Scale, also with some other companies as well. Elephant Scale is through the company through which I do training and other things like that. But I also work as a consultant for a number of companies in helping them gain value out of their data and work on in terms of data science and some data engineering too. So I consider myself a data scientist. One of the things we'll talk about here is how we can build a career in data science. And it is one of the, I think, the areas in that is one of the most important fields that is coming up in our world today. So why is it one of the most important? Well, one of the things that many people have said is that data is the new oil. So how's data the new oil? Well, what is it about oil that makes it valuable? Well, oil in the 20th century was something that we worldwide needed to fuel the economy, right? In fact, literally oil, once refined, we could use it to make fuel in order to make our economy run. And so people who, countries or companies that had access to oil in the 20th century became very wealthy, right? And we think of countries, for example, in the Middle East that became very wealthy due to their abundant resources that we had. Now, I believe in the 21st century that although oil is naturally still valuable, but the equivalent to oil in terms of the economy today is data, right? So companies that have data assets have things of great value. But much like oil by itself is, until it's refined, isn't so valuable. You can't really use it for too much. And the same thing with data, right? So we need practitioners who are able to take and gain access to data and make it valuable, turn into fuel, right? So what's data science? Well, data science is, and again, there's lots of different definitions for this. What I consider is data science is data-driven application development. So this is basically a new discipline, and it's fueled by several things that have kind of come together. First of all, big data, right? So we have a lot of data that we can mine these days. And there's lots of intelligence that we can mine out of this data. There's technology revolutions out there. So in the last 10 years, we've seen things like Hadoop as a big data platform and NoSQL databases that allow us to do big data processing when in the past we just didn't have that capability. And data science brings together multiple disciplines, right? So we have, of course, computer science, but also other fields like statistics, for example, mathematics, and domain expertise. So we'll talk about that. Now, Anand Ramarajan, who is from Walmart Labs, had said, and I think first, but is this, I think, one of the truisms of our world today, is that more data usually beats better algorithms. So that is that a lot of times a mediocre algorithm, when presented with enough data, and the right kind of data, can often outperform algorithms that are algorithmically better but don't have that data. So again, those who have the data are able to gain the most value. Now think about a particular problem that we have. Like, so for example, we're all familiar with LinkedIn, right? So when you log into LinkedIn, one of the things it says people you may know. Well, let's think about how does that work? Well, one way that we might want to implement this is we may just kind of collect emails, and if I, for example, have a contact with S. Ram Prakash here, then you might want to suggest him or recommend him as one of my contacts on LinkedIn. Okay, so and we might actually be able to do some analysis here and find out some things. For example, we might find out that if it has a photo like Ram Prakash here, he might be more likely to click on him than something else. And if it said, for example, you both know such and such a person, that might remove the creepy factor, right? Now, those kinds of insights, where do we get those insights, right? How do we know that you both know this person removes the creepy person or not? Well, that's why you need a data scientist. So you can see in this cartoon, before, nobody cared about math geeks and parties, but now people love data scientists. So, which is really just a rebranded math geek, right? So another person said that, a data scientist is a business analyst that's working in Silicon Valley. But a data scientist sounds a lot cooler on your CV or resume than business analyst does, right? But truth is that a data science has more asks than a typical business analyst. First of all, data scientists should have a firm grasp on computer science, right? So a data scientist has to be able to write software. So algorithms, data structures, different languages, et cetera. Also has a good knowledge of machine learning and kind of, engineering tools like Hadoop or Spark, et cetera. Now, but again, pretty much most developers probably could master that. So how is a data scientist different than a developer? Well, unlike most developers, if you want to be a data scientist, you need to have a solid understanding of probability and statistics, modeling, charts and visualizations, and other things like that. Again, most developers don't have that knowledge. So you'll need to have that knowledge to be a data scientist. And also, you need to have domain knowledge, right? So, for example, what that means is that, let's say you're working in banking. Well, you need to know something about banking, right? If you work in healthcare, you need to know something about healthcare. So unlike a lot of developers for whom they're just writing apps and they don't really care much about the domain, and a data scientist, that's not the case, right? So kind of differentiating between a computer scientist and a data scientist. Computer scientists are more about developing a product. They want to develop a quality software. But a lot of times they don't really care about data. Whereas data scientists is all about the data, and they're focused on gaining value from the data. Now, they're writing good software too, but the focus is on the data rather than on the product. Because of that, needs a deep domain knowledge to be a data scientist. But they have similarities. Both of these computer scientists and data scientists both know computer science pretty well. And of course, many people, myself included, approach data science from the background of a computer science. My degree is in computer science, right? So there's many people who come from that path. Now, what about data science versus business analyst? Now, both have to have this strong domain expertise. That's one thing they have in common. And also, they both need to be able to have good visualization. In some ways, data scientists are storytellers because they have to be able to narrate the story to the end users. And a business analyst has to do the same thing. But unlike a business analyst, data scientists have to code. That's, I think, again, a lot of times business analysts work with high-level tools or Excel or other things like that, and they don't really code. But data scientists have to code in languages like R, Python, et cetera. And typically, a data scientist is expected to go deeper. A business analyst may be focused mainly on reports. And reporting, of course, is very important. But data scientist is usually expected to go deeper than simply just presenting the data. They need to be able to generate insights from the data, go beyond that. As I'm sure you've many times heard this, the known unknowns versus the unknown unknowns. The things that we, the known unknowns being the things that we don't know, but we know that we should know them, versus the things that not only do we not know them, but we don't even know what we don't know, right? And so a data scientist is kind of brought in to bring some light into that. What about a statistician? Well, there's a lot of people who, for example, a good example is Nate Silver, who is the blogger from the political website 538. He considers himself a data scientist. His background is as a statistician. I think he has a PhD. So he's a great guy. I love his blog. One of the things he says, though, is he says basically that a data scientist is nothing more than a rebranded statistician. Now, he, of course, has a PhD in statistics, so he would think so. However, I think there are some differences. One thing is that statisticians typically don't have much skill in software engineering. So again, statisticians are mainly about applying the tools of statistics. However, data scientists, again, do have to be developers and they have to code, right? So there are also some differences between the methodologies of statisticians and data scientists. For example, statisticians tend to look at sampling as a really important tool. Data scientists might do the same, but data scientists tend to have a more is better kind of attitude when it comes to data. And there are, again, pluses and minuses with both approaches. But they both need to have a strong knowledge of stats and modeling techniques. So as we said before, the reports would be an example of the known unknowns. We need to know our sales numbers, we need to report, etc. The insights would be, is there a relationship between, say, this variable and this variable, right? So, and then also looking at maybe the relationship between bill pay data and clickstream data. So what's a data scientist, right? So a data scientist, we have somebody who brings together computer science, coding, in other words, right? Applied statistics, machine learning, domain knowledge, and visualization skills. And here, this person is going to be able to produce trends, insights, reports, products, etc. Now, this is a big ask. Now, part of the challenge is that it's hard. Let's say I'm going to hire somebody. It's hard to find a person who can do all these things. Somebody can code, but they don't know much about the domain. Somebody knows a lot about the domain, but they don't know anything about stats, right? You have somebody here who is a professional statistician, but they may not know things. You get the idea, right? So finding all these things in one person can be difficult. Okay, now that's why, though, data science, again, we are responding to the need. There is a need to have practitioners that are data-focused practitioners, but also can lead digital transformation efforts. And that is kind of what brings data science. Now, let's talk about how we do data science. So we talked a little bit about the skills that you need to be a data scientist, but what are the things that you actually do as a data scientist? All right, well, let's talk about that. Okay. Let's say you are hired as a data scientist and you are given a problem from your boss. Your boss says, we want to have better ad targeting to improve the click-through rate. Now, there's many applications for this. Actually, right now, we're in the middle, in the United States at least, I know some of you are coming from abroad. United States, we're in the middle of election season, and massive amounts of money, unfortunately, sometimes good, sometimes bad, are being spent in order to target messages to various people. And at one time, this was mainly done in a very general way. We would be trying to target messages to everybody. Such and such a candidate is better at the economy, say. Such and such a person has a better plan. But that's not really how it works much anymore. Now, we have very specific messages that we want to get out to very specific people. Okay. Now, not only in politics, but also in advertising and many other areas. And in fact, this is pretty much what Silicon Valley is all about. How does Facebook make their money? How does Twitter make their money? How does Google make their money? They make their money because they tell their providers, hey, I'm Google and I own YouTube. And guess what? Everybody on the planet watches YouTube. And guess what? We know exactly everything that they watch, and we have a really, really, really good idea of what they're about. And so if you want to get your message to them, we can help you with that, right? So again, you know the idea. So ad targeting, this is something that requires an incredible amount of knowledge. And that knowledge comes from what? From big data. And Google has thousands of data scientists who are working on this, right? Now, Google's probably better at this than we are, but let's try to kind of learn from what they do. Okay, so that's our problem. Our problem is better ad targeting to improve the click-through rate, right? If you are an advertiser, you want people to click on your message. And one way you can measure that is, well, click-through rate, right? How many people click on the link or whatever that you're trying to get, right? So if you send out a link to anybody and everybody, then your click-through rate is likely going to be very low, right? But with targeted messaging, you're going to see what kind of messages are getting results by clicks, right? So, all right. So what kind of data sources do we have, right? So data science, remember, is all about data. So the results are going to be entirely dependent on our data. Well, what data do we have? Well, companies like Facebook, what is it? So social data, right? What are they actually doing? Are they trying to make a cool service that you can connect with your friends? Well, sort of. That's indirectly what they're, yes, I mean, that's what they'd like you to think they're doing. What they're really doing is they're collecting a huge amount of data about you, right? Now, again, there's a lot of ethical concerns here, and a lot of people have privacy concerns or whatever. But whenever you use Facebook, you are sort of making an implicit deal with Facebook. You're saying, hey, you're giving me this service that I value, and in exchange, I'm allowing you to collect some data about me that you're ultimately going to sell to advertisers, right? So, there's many other kinds of data sources as well, right? So Google, for example, knows a lot about your searches, right? Those kind of searches, there are more data it can use, right? So again, we have lots of different data sources, and there may be very disparate data sources that we might have, right? So, all right, so we need to collect this data, right? So, and that's an incredible management perspective. We also need to prepare the data, build, train, and test a model, and we'll show our results. So let's talk about all these things. Now, we define the problem, better ad targeting to improve click-through rate. Now, that's a pretty well-defined problem, but defining the problem isn't as easy as it seems. So let's pick that apart. Better ad targeting in order to improve our click-through rate, right? So we say that we want to better target ads, but in order to make this a good problem, we need to specify a clear, measurable metric that we're going to say. I could say I want better ads, right? But okay, how do I measure what's better ads, right? If we're going to need the help of a data scientist, we need some kind of metric that we can, a numerical metric, right? Click-through rate is a numerical metric. So we can go ahead and define those terms. Now, again, I could just say known knowns. What is my daily web traffic? How many people are clicking on my site? Okay, well, we can do that, and we probably should do that. We're probably already doing that, right? But we might have some questions. So, and so, give me a second here. And so we might have some questions about that. For example, we might say, so what are some of the most popular web pages? We might also ask about what are their big connectors that matter in a social graph. Okay, so those are some questions that we might want to answer. Finally, we can ask, is there unknown unknowns? So for example, is there a connection between X and Y, right? So that is one of the questions that we're going to be able to ask. So, okay. All right, okay, so when we collect data, there's a lot of different places that we can get data. In fact, there's whole companies whose whole job it is to sell you data of different types, right? So, so there are various places. There are challenges to this, privacy challenges, for example, compliance, security, how much can we get? Is the data in a usable format? We may need to bring data from different systems together. And there may be different types or different formats of this. This is a challenge. A lot of what we're talking about here kind of straddles between data science and data engineering. In data science, of course, we're going to talk about analyzing, modeling, mining, etc. But in order to make that effective, we need to engineer a overall infrastructure that can help us in managing all of these things with collecting data. And in fact, once we've kind of done a proof of concept with our data, we may need to do analysis on that data. We need a data pipeline, bring those in from multiple sources. We can bring them to a central place, etc., where analysis can happen. We can handle failures in data flow. We can set up governance policies, etc. Data is increasingly becoming a much more regulated area. EU, for example, guidelines in GDPR, etc., in data protection, privacy, etc., are leading all these things in order to have to manage data in an ethical, responsible way, and a way that we need to have compliance. So this whole area of collecting, processing data is one that is fraught with a number of pitfalls that we have to be able to overcome. Another one of the pitfalls is the fact that data sources are often very messy. And in fact, data scientists often spend most of their time actually cleaning up data. Now, processing, massaging data. This isn't probably what most of you who came to this webinar wanted to sign up for. You didn't kind of, wake up every day and said, I'd like to go clean up a bunch of messy, dirty data. But unfortunately, whether it is the glamorous part of your job or not, it is something that is going to consume a lot of time. The thing about it is that when we talk about what's going to produce a good model and a good result, by far the most important thing that goes into that, by far, is the quality of your data. You have good data and enough of it, then you're going to get good results from your model. On the other hand, if your data is garbage, you know what they say, garbage in, garbage out, right? So again, this is really important, right? It also is not very glamorous or exciting, but one of the things that we have to do. Now, when we deal with data, particularly big data, you need to understand what you have. And the thing is that you can easily eyeball like 20, 50, 100 rows of data, but eyeballing like 1 billion rows of data, just not possible, right? So you need ways to understand. So this is where a background in statistics can really help. Now, I'm not saying you have to be a statistician or go out and get a second degree in statistics, but of course, statistics gives us a lot of tools into helping us understand our data. So for example, we can ask, is there a pattern, right? So when we look at variables, is there a pattern between our variables? Are there a lot of outliers, right? So outliers can skew our analysis. So we have questions. Should we keep them? Should we throw them away? Maybe we're primarily interested in outliers, right? So for example, if we're trying to look at student performance, maybe we're primarily looking at the factors driving the most exceptional students who are by definition outliers, right? So again, we have to decide though what we're going to do with outliers. Visualizations can really help, right? Now, when we do visualizations as data scientists, there's kind of two very distinct kinds of visualizations we do. The first is what we're talking about here. They're trying to help you and your teammates understand the data in order to get good results. Later on, we'll talk about visualizations that will ultimately be for your end users, which are going to be more about narrating a story to them. Those visualizations will likely look quite different. Now we look at this and we say, are there interesting segments here? So for example, we might say, in this case, we see these various groups here. There's something going on kind of in the range of this variable from here to here that looks quite different from here. So, that's what we have here. So, okay. Now, when we think of data science, probably the first thing most of you, if you know anything about data science, you probably think of is building models. And model building is really important. For a data scientist, is much like the software. If you're an application developer, your end product is some program, right? For data science, it's going to be your model. But you want to make sure before you even start doing modeling that you already have a good understanding of the data. And you've done a lot of job in terms of getting and collecting and cleaning up and all the stuff we talked about. Now, you also have to pick the right modeling technique, right? So what are we trying to do, right? So are we trying to say classification? In other words, are we trying to identify something as this, this, or this, right? Are we trying to cluster it? So we're trying to look at the relationship between data, right? So all those things are different kinds of modeling, and those are all different tools that you'll have in the toolbox. Now, you want to pick the right model for what you're trying to do and not to get too hung up on one model. This is a place where experience really counts because as you have more experience with data, you'll have a better sense of where modeling is appropriate and what you can do. Now, one of the things if you as you work as a data scientist, you'll know is that anybody can take some data and throw it at a model and get a model. Is that model any good? Is it really valuable? How do we measure that? And one way we measure that is by doing model validation or testing, basically. A model that hasn't been validated is basically worthless, or even worse than worthless, because it's giving us results, but we have no idea whether those results are meaningful at all. Then in data science, we have a problem called overfitting, in which we have a model that seems to work well in training data, but won't give us good results in real life. And model validation is a way to help us ensure that our model will generalize to real life. Okay. All right, so we have a model. So a model is, well, what's a model, right? A model at the end of the day is just kind of like a modeled airplane or a model car, right? Just like, what are those? Those are kind of a representation of some observations of the real world, right? Same thing with our model, right? So now we have this model, which we hope can help us inform our understanding of the world, right? Can help us to make predictions, say, for example. Can help us have deeper understanding of the trends and whatever. Now, then we have this great model. What do we do with it? Well, a lot of times data scientists feel that their end result is a model, but in fact, a great model alone isn't necessarily going to help your company, right? For example, let's say you had a killer model that could predict the price of the stock market with a great deal of accuracy. That'd be an outstanding model if you could really do that. You could make your company millions of dollars if you work in finance, right? But again, that model by itself is only valuable to the extent it can help inform decisions to decision makers, right? And how do you do that? Well, one of the things about humans is that humans are very visual, right? So actually, as data scientists, many of us have a good background in abstract thinking, right? And so, if you are interested in a career, one of the things that you can do is, of course, being able to visualize let's say, abstractly is something that will help you in data science. But your end users are probably not like that, right? So what do we say? A picture is worth 1,000 words. Humans are very visual. I mean, when people go out to buy a house, a lot of times, a floor plan will do nothing for them, right? They need to see it before they really have any idea of what that house really looks like, right? And so your users are kind of the same way. You may be able to visualize what that model is trying to tell you, but you need to tell that to your end users who probably can't visualize that kind of abstraction, right? Again, we all have different gifts. So your business users probably have their own value that they bring to the table that you don't, right? Again, we all have our own points of value, right? So so remember I said before, in many ways, a data scientist is a lot like a journalist. So a journalist, what do? Well, they go out, they gain information, and they summarize and help narrate that information to their viewers and help kind of tell a story, right? Same thing with data scientists. We are in some ways doing the same thing. We're taking something that's very complex, probably far beyond the ability of our end users to quickly grasp, and we're trying to narrate a story. Now, at once upon a time, you might do that with some line charts, bar charts, scatter plots, etc. All those are certainly valuable. But our users actually now have a lot of higher expectations. They want to be able to interact with the data, right? And there's another way, it's kind of like journalism. In a lot of cases, data-driven journalism has led interactive visualizations that can help the user be able to kind of play with to understand the data interactively. And there's a lot of tools for that. So, all right. So we talked a little bit through an application of data science. We talked about an application of data science to some Silicon Valley kind of stuff, ad targeting. So you might say, well, I don't work in Silicon Valley, and that isn't interesting to me, right? So, well, it turns out that most companies are going to be able to need data scientists. So for example, if you work for a lender or a finance company, risk analysis. Again, what does that mean? Basically deciding, whether or not you should, say, lend money to somebody and at what, say, interest rate, right? because you're going to try to analyze the risk. Very complex modeling goes into that, and data scientists can really be helpful there. Any kind of predictive modeling, right? So ultimately, many companies would like to know the future. Go all the way back to the Oracle at Delphi, right? People would come all over because they wanted to know the future. Well, in a lot of ways today, the equivalent of the Oracle at Delphi is the data scientist, right? So, again, things like the stock market, things like home price, things like many things, right? Now, nobody really knows the future, but again, to the extent that looking at past data can help inform the future, can help give us an edge, right? Recommendations, right? So when you go to Netflix, right? Let's say you're an anime fan and you go there and lo and behold, like you think like the whole world, all they look at is anime because when you go there, Netflix, it's like anime everywhere, right? Well, Netflix knows something about you, right? They know you like anime. Recommendations is so far beyond that though. In fact, as our experience with the web comes, it's really driven by basically recommendation. Probably if you, in most sites, if you see some content, it's because the algorithm thinks that you want to see that content. And a lot of content you probably never see, or at least it might be may take a lot of searching to find, because again, the recommender doesn't think that that's something that you would be interested in. Fraud detection, social media analytics, there's so many areas. And all these you can see here are applications that we have of data science. So we talked about here, the process of data science is really iterative, right? So it's not as if we go through, we start out, we collect our data, build our model, validate it, and visualize, right? It is an iterative process where we're collecting data, we then build some models, we look at those models, we try to visualize results, then we say, hey, wouldn't it be interesting if we looked at this? Or maybe there's some other data that would be good. Or maybe we can do some additional cleanliness of the data. Maybe we could try a different approach to our output, right? So it's an iterative process, right? That we're going and ever gaining a better understanding of what we have. Now, you notice one thing I haven't talked much about yet is tools, right? So, well, traditional tools out there are things like SAS, SPSS, etc. Those tools often were designed for very specialized people, had, astronomically high, and still do have very high licensing costs because they're generally designed idea for, a single or small group of practitioners. Now, the open source tools like R and Python are exploding in popularity. And of course, in many cases, these open source ecosystems are free, but also they have a huge ecosystem, right? With thousands of people working on them. I would say that the trend has been toward open source tools like R and Python becoming an essential, if not, essential part of what we consider in data science. And typically, if you're going to be a data scientist, you'll need to probably know and use either R or Python or both very well. Now, Java language, as we see here in this list, is not so popular among data scientists, but it is very popular in terms of the software to which the results of data science might eventually live, right? And so therefore, all three of these languages become very popular there. So now, R as a language is a language designed by statisticians. So it is going to be very specialized toward kind of statistically driven programming. Python tends to be, it's probably the most popular language used in data science. And that's because it can be used for a lot of kind of more specialized data-centric work as well as AI, but also is a pretty good general purpose language, right? Now, Java is a general purpose language as well, and probably not as strong in the area of data science, but again, an area where a lot of data science work will eventually live because, again, Java is probably the most popular server-side development language, right? Now, we said before that one of the things driving data science forward is big data. And so all three of these languages are able to integrate with the big data ecosystem by using some frameworks as part of that ecosystem, the most popular of which is Apache Spark. So we mentioned here that we can do that in R, Python, or Java in terms of languages. Okay. All right, so I've talked a little bit about data science. So where are we going from here? Well, so one of the things we have here is the Internet of Things. So virtually everything in our lives now is generating data, right? So even things like your microwave oven or your refrigerator or your car, whatever, generating massive amounts of data. Sensors everywhere. And as a matter of fact, already even now, traditional kind of devices like PCs, et cetera, are are a minority of the amount of data that's being generated, right? These other things as well. And analyzing that data is extremely important, right? And being able to do that. Another thing is real-time machine learning, right? So traditionally, modeling has been kind of a batch process. We gather a bunch of data, we train a model that could take hours, then we deploy a model, then maybe, if we get some new data, we kind of go and repeat the process. But a lot of applications, think about things like self-driving cars. These is very much a real-time process, right? Yes, of course, we have models we may have pre-trained, but that model has to be able to, in real time, be able to react to new data. So real-time modeling, right? There's a lot of applications for that. Now, deep learning is probably one of the most exciting areas of artificial intelligence that is applied to data science. And deep learning is becoming incredibly important, particularly in areas like, say, computer vision, natural language processing, and other kinds of areas where we're looking at sensory type data. Extremely important there. Okay, so maybe you're saying, hey, this all sounds really interesting. Where should I go from here? Okay, so one person's name you should probably learn is Dr. Andrew Ng, NG, from Stanford University. So he has some excellent courses online from Coursera, and also you can just find his stuff on YouTube, in which he provides thousands and thousands of hours of content for free for the most part, or at least at very nominal cost. And his focus is on topics around data science, AI, machine learning, et cetera. So now, I will mention his course is fairly mathematically intensive. So if you need to brush up on your mathematics and statistics, you'll probably need to do that. A couple other resources I have here: Machine Learning for Hackers. This is a tool that's made primarily for developers. That's what they mean by hackers. Not necessarily, we're not talking about the bad guys necessarily, but just developers, right? So they have a lot of good examples in R language by Conway and White. Information Theory, Inference, and Learning Algorithms. This is actually a text I had in my graduate education by David Mackey. You can actually get this online. It's a free downloadable PDF. It'll give you a good background in theory. Another kind of good theoretical book is Bishop, Pattern Recognition and Machine Learning. Again, another academic-oriented text. The Elements of Statistical Learning by Hastie, Tibshirani, and Friedman. Again, these last three are texts you're likely to find in kind of sort of courses that you might find at a graduate level. And those are good resources. Again, go ahead and take it from here. Now, one of the things that I mentioned here, I think one of the biggest barriers to people who want to learn this whole area of data science, machine learning, et cetera, is that a lot of people, especially if your academic background has been a few years ago, is a lot of people are intimidated by the mathematics and statistics. And the thing is that this is a discipline built on mathematics and statistics. And for some people, that may be intimidating. Now, what I would say is there are different levels of understanding. And I feel like there are certainly ways that you can get involved in data science, et cetera, and incorporate that. And, even if your background is not at the, kind of graduate level, right? And so, as a practitioner, your understanding will grow as you incorporate more of these things into your workflow. So I would not recommend that you feel like you have to run off and get a degree in math and stats before you begin. Again, you should be able to kind of grow into that as you develop your skills. Okay, so that's all I had for this. I wanted to now open up some time for questions. So feel free to use the question. Yes, I see that raised hand. Anna, if you can, I'm not sure if you're muted or if you can type in the Q&A, anything, but I see that that raised hand. So go ahead and ask that. So. Let's see here. All right. I see the raised hands. I'm guessing probably most of you are muted or something. So let me go ahead and see what we have here. Ah, yes. Anna, I clicked on.
Okay, yes. Hello. Thank you for the talk. I am also data analyst, and I am thinking about what should I do for my career for next 10, 15 years. And I was thinking about going deeper in machine learning. But is it a good idea to invest 2 years of education for Masters of Machine Learning?
Well, I think, an advanced degree in machine learning or in data science, you're seeing in the last few years that these types of degrees have popped up in graduate level. And I do think having a graduate level education could be very valuable, particularly if you want to have a really, really deep understanding of this. So I do think it could be valuable. I do think that, self-study could also probably accomplish that if you're disciplined enough to be able to do that yourself. So yeah, I think either formal education, which of course, having a degree has certainly a lot of demonstratable value. I do also think self-study could be valuable too. I think there's a lot of companies out there who are willing to hire somebody who can demonstrate their mastery of the content, even if they don't have a formal degree, right? So I think either one can be valuable. And given the choice, probably the formal degree would be even more valuable. But again, I think either one could be there. And I do feel like things are moving in a sense that data science as a career is going to become increasingly important, as I said. So I do think it would be well worth it to invest your career in that. So,
yeah, that's my question actually. What will be needed in next 10, 15 years?
Well, I think is next 10 or 15 years, I think we're seeing the growth of companies well beyond Silicon Valley that are needing people who are able to make real value and benefit out of large data sets and have the skills to be able to really do that. And the traditional data analyst alone probably doesn't have those skills, right? And so I think, going deeper technically in that area could really help. What I see a lot of companies have is they have a lot of data analysts who are strong on the business domain side. And you have a lot of software developers who are good, solid developers, but there's nobody in the middle who are really able to help them get sort of real value kind of in today's sort of data-centric world, right? And so the data scientist is a person who can really help them gain that value, and it's an incredibly valuable skill. So, yeah.
Okay, thank you.
Yeah. Abdul, I see your raised hand, so go ahead and unmute.
Thank you so much for letting me to speak.
Yes. Yeah.
My question was regarding my career. I recently completed my graduation in computer sciences.
Okay.
I am doing a short course, artificial intelligence. But the main question is that, as might be, I am in the Pakistan, but technology is the global village. Okay. The question is that could I start by learning myself, or I should take a master degree in data science, or move some other country like US or something else, European country, or should I study or learn by myself? What do you recommend on it?
Well, I mean, a formal degree certainly is helpful because it can very quickly say, I have a master's degree in this field. It can certainly be a good way to demonstrate your credentials, right? So certainly it's helpful. Just like I said with Anna, though, I think knowledge is probably the most important thing, right? So if you can demonstrate the knowledge and mastery of the subject, then that is the most important and valuable thing. of course, getting a formal degree is, I think it's great, you know, if you're able to do that, but I wouldn't discount the possibility of just doing self-study. Again, in a technology-oriented world, being able to demonstrate and apply mastery is the most important thing, right? More so than formal degree. But of course, I mean, if you get the chance to have a formal degree, then go ahead and take it. That's a good thing too. And so as far as what country to go in, I probably can't speak to that, you know, but I do think it is true that in the world we have today, definitely a lot of work is being done all over the world, right? In kind of that, you know, internet connected world. So I think, you know, there's definitely possibilities for you there, probably in your, you know, in your own country too, or wherever. So yeah.
I have another question. May I ask, please?
Sure. Yeah.
Another question, as I see the web and development of web and Android, the application is create front end, back end, and the functionality. In that field, the field of artificial intelligence and the data science, what would be the product, or where is our domain, and where we will be utilized in our future or in our company, or where will be we as a data scientist, where will be usable for the company and our career? What is our position?
Well, most mobile applications actually do have a pretty strong data science component. You know, of course, so for example, if you're dealing, you know, some of the applications, for example, the camera app on your phone, right? There's an incredible amount of AI, data science, et cetera, machine learning, kind of all those areas that go into that one thing, essentially, right? And so, and I think that's accelerating, right? I think the application is, you know, one, so not, you know, again, the applications that you have are going to be very much informed by AI and data science, right? So, you know, when we're looking at, say, a news application, the news that you see on the news application is very much driven by algorithms, right? So yeah, I think, you know, now, because that's going to fit more on the back end than the front end, but definitely as part of applications, it's an important, the data science aspect of that is becoming increasingly essential for really any kind of application that has to deal with real world data, right? Whether that be text data, whether it be images, whether it be, you know, any kind of data that you have. I mean, it's really important. And I think it's moving away from just a few Silicon Valley companies like Facebook and Google and into basically every company. So yeah. Here, we have a few more questions here. I see Andrew there. So go ahead, Andrew. Yeah, so.
Hi, Timothy. Thanks for the talk. I have a background in software development, data and machine learning engineering, and I decided to pivot into data science. I don't have an undergraduate degree. Do you think that this would still be a barrier?
Well, it would probably for more traditional companies. I mean, there's a lot of more traditional companies that are probably, frankly, not going to look at you too seriously without at least a bachelor's. Although, if you had one from, you know, just, you know, again, you could get just a kind of a nominal bachelor's, some online course. I mean,
yeah.
So that, I mean, so now as far as like a lot of kind of Silicon Valley startups and stuff, I mean, a lot of them probably are less concerned, but you would have to be able to demonstrate your credibility. I mean, that would, you know, again, but you know, one way to demonstrate your credibility would be, you know, contributing to open source projects, for example. Like, so for example, if you, that's one thing I often recommend to people, if you don't have, you know, if you don't have a lot of experience, especially in your case, since you don't really have an educational experience, being able to say, hey, you know, my name is such and such, and I am a contributor to this, and this open source products that you've heard of. And it's not hard to become a contributor. I mean, usually open source projects are very happy to take free help, right? So it's an area where you can build your credibility. And I think with credibility, a lot of startups and stuff will probably be okay with that. Yeah. So it just depends on the company.
Great. Thank you.
All right, let's see. I see Cynthia. Is there? Yes.
Sure. Hi. Thanks for the presentation. I've been learning a lot from the questions and the presentation. I just wanted to say that my personal background, I have a bachelor's in the health sciences, like no professional degree, and I think I got a master's I got an MBA with a concentration in say data project management, in which I think I was trained like on the very like introductory level of a data analyst or like a data management professional, in which I learned some Excel, I learned a little bit of Oracle SQL, like beginner and intermediate, and I learned some like business intelligence project planning methods and techniques. Although I was not particularly like heavily versed in Tableau or like heavily versed in like the popular data analyst or business intelligence packages. Like I wouldn't I wouldn't call myself a business intelligence personnel of any kind at that point. But I think that because I was trained as a data management personnel, it makes me have to work harder when I self-train to teach myself things like statistics, computer science, or the data science. I have no specific trouble learning a programming language per se, but the thing is, I find that it's like a punishing amount of effort. Not only do I have to like learn the tools that I need to become a data scientist, but I have to like retrain myself to take statistics or take statistics, but take it in a way that's going to reflect data science, not just a generic ordinary math. And in my saying that, what happens is that I have to be very careful with some of the MOOCs that I take. Not that they were bad things of itself, but I began to notice that sometimes after a MOOC, I noticed that I learned the bare skeletons of Python coding or Python data analysis, but then often find that I need to learn much more. Like I don't feel like I'm hackathon ready, or I'm not like all in shape with I'm not all in shape for things right now. You know what I mean?
I do agree that in the area of data science, it's kind of like an interlocking set of a number of difficult skills. And if you don't have that sort of the whole set, it becomes difficult to be successful, right? Because, for example, and I do understand that is one of the challenges that we have, right? Because to really be effective at data science, as I was kind of saying before, you're going to need, to have not only like a set of tools, but also a set of kind of knowledge, as you mentioned, statistics being one of them, but certainly not the only one, that you'll have to have at least some comfort in that area in order to be successful. And I know it is a challenge because I think a lot of people give up because they, basically, they feel like it's just a huge amount of new skills all at once. And it's difficult to be successful with just a limited number of those. So that is difficult, but I guess my only encouragement would be is not to give up, I guess. I think like these skills certainly are things that you can kind of learn on the fly. One thing I would mention is that I think that I would not recommend, probably many people probably do approach data science with an insufficient background in mathematics and stats. I mean, that's pretty common, right? And so what I would not recommend doing though is basically signing up for a bunch of math and stats classes. The reason why is that you're likely to lose heart just because they can be long slog in that, right? So what I would probably prefer to see you do is kind of over time, kind of improve the math and stats background as time goes on, as you're doing it, right? So take more of a practitioner's approach. At first, some of the math may be a little bit foggy for you, but if you take a practitioner's approach, go and try to get some good results. You can go fairly far even with a pretty shallow understanding of the math. And then, of course, as you kind of gain sort of a kind of more high-level view of it, then you can over time be able to become more comfortable with that side of things. So.
Yeah, that's what I'm doing. When I first got like only a skeleton bits of training at university level, I was so overwhelmed because I had like nothing to speak for in terms of my resume or even like telephone interviews, and I was so embarrassed that I almost gave up, only to learn that a few years later it was a big mistake. I could have pushed a little bit harder on, even in small incremental steps, but I was so confused and overwhelmed with the information that I got that I didn't know what to believe or what to follow, and I felt that maybe at the time it was like maybe data science or business intelligence, maybe anything related to the data just was not standardized enough to know what you needed, or like people.
Yeah, it's a challenge. One of the reasons why it's such a lucrative career is that it's intimidating, and the world needs a lot more data scientists than there are a pipeline of individuals like yourselves who are doing it, right? So if you are successful in rebooting your career in that way, you'll be one of a area which there's a shortage. There's going to be a shortage for a long time. Right. And so that's one of the reasons why it can be so promising for your future. But again, it is challenging. This is not like learning some new, web framework. right? I mean, this is a challenging thing that's going to require a whole bunch of really difficult skills. But again, I'm saying, like, keep at it. This is a marathon and not a sprint. You just got to keep at it, keep going, and you can be successful if you're willing to put in the time the time and energy to learn it. So, yeah.
Okay.
Yep. Let's see. I have a few more people here. Sundar, I see that you raised your hand. So. Sundar, are you there? Sundar? I think you had raised his hand.
Yeah, are you able to hear me?
I hear you, yeah. Uh-huh.
Okay, sorry. My question was around someone doing a self-learning on data science and machine learning.
Mm-hmm.
Where would we go to get some meaningful projects that are kind of resume worthy, instead of just doing simple projects? If you need to take real life complex data sets and do some meaningful projects with it, I was asking for some sort of a resource where we can go get that and execute it and get some real life experience.
Real life experience is a bit hard to come by, but there are some ways that you can do that even with no experience. You can do Kaggle competitions and other similar things like that. I'm not sure if you're familiar with Kaggle competitions, but they are, again, will take anybody as long as you're willing to participate and put in the time. And a lot of companies do, in fact, contribute very much real world data sets to Kaggle competitions because they're hoping to gain some insights from the participants. So it's usually heavily anonymized and all that, but you can definitely do that. Another way, again, as I mentioned with somebody before, is if you're able to contribute to open source projects, then those, again, are usually very happy to take contributions from virtually anybody. Again, if you don't have a lot of skills, they may find more mundane tasks, but nevertheless, that is a way that you can build credibility because, if it's on GitHub or something like that, just, if you're a potential employer, you can just give them your GitHub ID and they can easily see immediately like what kind of contributions you did, right? And there's, and that's kind of speaks for itself, right? So I think there are a lot of ways, even if you're a student or you have zero experience, that you can very much be involved. And I think for those who are willing to work with the payment, I mean, there is, of course, we all want to get paid, we hope, but again, when you're starting out and bootstrapping, then there are certainly ways to, kind of make some contributions with minimal to no payment, but in the process build your credibility. And those are some ways that, again, if you can show that you won Kaggle competitions and other things like that, or even did respectably well, that is itself something that speaks to your experience. So. Yeah.
Okay, got it. Thanks.
Good. Any other questions here? Let's see here. I'm trying to see if anybody else had raised their hands. All right. Well, I think, yes, that wraps it up. So, and we're about out of time. So, oh, actually, hang on. I'm looking at a few QA questions. Sorry, actually. So, actually, let's see. Somebody asked, is it better to learn one language, R or Python or Julia, for example, at advanced level, or try to learn the basics? Well, you got to start somewhere. I use both R and Python myself, but I use Python more. And if you only had to pick one, I would maybe recommend looking at Python. Again, it's kind of a debatable point, but I think, though, certainly there's probably some value. I don't know. I mean, I would start out with probably one, so pick kind of there. Python is generally a better general purpose language. And if you don't know, I would recommend it. R, of course, for some, though, especially if your background is in statistics, that might be a better choice. So, okay, so Ken asked, what's a good source for learning machine learning? Well, there's a lot of big, MOOC courses out there. There's a lot of resources online that you can do. It's not actually, there's plenty of materials out there. It's just that sometimes those materials can be difficult and you take a lot of effort. But, for example, Coursera, there's all kinds of stuff on YouTube. I mean, there's also a large number of books. I kind of mentioned a few of them. And in fact, there's a lot of free resources out there. So there's really, again, it's not so much the lack of materials, it's the fact that, sometimes materials can be pretty dense and it takes a lot of effort and endurance. Yeah. So, Cynthia asked, what if you can't afford an institutionalized education? Then I wouldn't let that stop you. I think, you know, a formal education gives you two things. It kind of is, it's sort of, you know, again, if you're not very self-disciplined, it can kind of give you that sort of structured program. But if you're self-disciplined enough, you may not need that, right? And the other thing is it gives you a degree, which does have value. But I'm saying I think it's not, strictly speaking, essential to have the formal degree. You know, again, if you can demonstrate your knowledge in other ways, then I think that would be okay. But again, if I do think there is value to having a master's level degree or higher. I mean, it is valuable, but I'm not sure, though, I would necessarily say it's the right choice for everybody. For some, just a bachelor's and a lot of self-study and you know, contributions to open source, all that might be just as good. So, where can I work with projects related to machine learning and data science in general? Again, you know, I mentioned that before. I'd look at Kaggle competitions. I would look at contributions to open source projects, etc. Again, you know, just if you have no idea, start out by looking at popular packages that data scientists use, like scikit-learn or pandas or TensorFlow or other popular packages. Again, they have lots and lots of ways that you can contribute. You could write some examples, you know, you could try to write some tutorials. I mean, there's a million ways that you can contribute, and saying, hey, I'm a contributor to the pandas package that everybody uses and knows. I mean, that itself is something that is going to give you some credibility, right? And so, yeah, so again, somebody said, as a beginner who only lately knows about data science, how can I start? More specifically, what would I know first? Well, I would say that if you don't know anything, where I would start is you do need to get comfortable with either Python or R language, right? So those are our kind of our languages of choice for most of us. And you really do need to know one of those, you know, two. So if you don't know anything, I would get started with one of those. Now, that's not enough. Simply being a Python or R developer by itself doesn't make you a data scientist, but it does at least kind of get you in an environment that you can kind of start doing some data science. And somebody said, what is a type of open source project? Well, that's a good question. What I would recommend is that look at various kinds of popular tools, right? You know, that data scientists use, like, you know, whatever, you know, and you know, one way that you can do that is maybe trying to help them, you know, ask the teams of theirs, you know, how can you help, right? And so I think those would be some things. I mean, you know, again, the approach of teams, open source community is usually very open to, you know, people coming and asking to be a contributor. So I'm kind of shocked at how few students and other people actually do that, you know. Also, another thing is that there probably are companies out there who, if you look for jobs, you know, find companies that are posted for jobs and say, hey, I want to help you for free. You know, again, companies that are underfunded, you know, again, they may be willing to work with you. Not all of them, though. Some of them will basically say, nah, it'll cost us more money to kind of get you up to speed than it would even if you do it for free. But there'll be some out there who probably, you know, they need money. Just volunteering to work for free is always probably a good way to do that. And as a matter of fact, way back in the day when I was a student, I volunteered to work for free at a company. They took me up on it. It was a great resume builder. So, you know, I think it's a good thing to do. Yeah, okay. So good. I think that kind of rolls it out. Anything else before we sign off then? All right then. We'll sign off then. Thanks everyone.